Apart from Ed, we have three heavyweight panelists joining us today. The first one is supposed to be Mr. Edwin, the Assistant Director of Journalist Services Department. But unfortunately, he has to attend to some medical checkup, and that's why he's not able to join us this afternoon. Instead, we have Ms. Joy Lee joining us. Joy is a civil engineer by profession, with extensive experience in planning, design, and construction of infrastructure, in particular, drainage works. She is now a senior engineer of the climate change section of the Journalist Services Department of the Hong Kong SAR government. She is responsible for formulating flood management strategy to combat climate change and the drainage improvement measures for the department. We now have Joy having a short presentation and followed by the discussion. Joy, please. Joy? Yes?
Yes? Yeah.
Yes,
yeah.
okay.
Hello, can you hear me? Yeah?
Yes.
Yeah, thank you. Yeah, good afternoon, all guests and friends. It's my pleasure to join this annual conference and share with all of you what our department, Journalist Services Department, DSD in short, is doing on echoing the main theme on this, how we're surviving the climate crisis. We all know that Hong Kong is a congested urban city with hilly terrain and high rainfall intensity. Under this setting, DSD has developed a three-pronged flood prevention strategy. It includes interception at the upstream area, storage at the midstream, and drainage improvement at the downstream area. With all the effort put, we managed to reduce the flood risk and eliminate over 100 flooding death spots from 90s in 1995 to now only 4 this year. However, climate is changing, so the mean sea level is rising, and there will be more extreme rainfall and more serious storm surge during passage of typhoon and the climate change. All this will definitely increase the flood risk to us, being a coastal city, and especially for the low-lying area. So the question is, how we are going to tackle it? Apart from the traditional structural engineering solutions, we are now introducing resilient solutions to address the residual flood risk. Here are some examples of resilience measures, such as the installation of demountable flood barriers or bringing up the E&M equipment to a higher level. In case of flooding, these measures can minimize the economic loss and maintain the normal functioning of the equipment. Compared to the structural engineering solutions, resilience measures sometimes are more flexible and cost-effective. As for new development areas, the concept of floodable areas is worth mentioning. Taking Hong Shui Kiu new development areas as an example, recreational areas such as water pond, sport grounds, and green areas can serve as temporary storm water storage areas. This will greatly relieve the stress to our drainage system during the extreme rainstorm. Recently, the government has identified 26 number of coastal low-lying or windy residential areas with flooding risk. For locations which are in threat of storm surge during the passage of tropical cyclones such as Diao, early warning system has been set up to reduce the impact to the nearby residents. When the Hong Kong observatories predict that the sea level at Tai O will exceed the preset alert level, they will alert us by sending our warning message. We will then deploy emergency response teams to set up relevant resilience measures to relieve the flooding impact. One of the major causes of the flooding is the blockade of drains by silt, debris, or rubbish, etc. So in the cooperation with the Hong Kong Observatory, we can have some rainfall forecasting on district basis. This can help us to carry out just-in-time clearance for the drain as though vulnerable locations before the heavy rainstorms. We also make use of the latest technology to employ the silting robots or the development of hydrometric information system to provide us real-time information on rainfall and sea level. To ensure the proper functioning of our facilities under extreme weather events, we are undertaking consultancies to develop schemes on enhancing the resilience of our critical infrastructures. We also have started a strategic planning study with an aim to develop a new flood management strategy to address the flood risk brought by climate change. We understand that we could not just rely on resilience method, nor we should just count on structural engineering solutions. We have to do both, and each should complement the other. Finally, I would like to say that support from the general public, as well as every one of you, is the key to our success. With the continuous effort from all of us, I think we will be able to build a better Hong Kong for the future generation. Thank you.
Thank you, Joy. Our second panelist is Dr. Tony Lee. He is the Operation Director of MTR. Tony joined MTR in 1991 and has held various management positions related to the design, construction, operations, and maintenance of the railway system in Hong Kong. Tony is responsible for managing MTR's railway-related operations in Hong Kong. He is a member of the advisory committee of the Department of Electrical and Electronic Engineering of the University of Hong Kong and the Engineering Discipline Advisory Board of the Hong Kong Institute of Vocational Education. Let's welcome Tony.
Hello. Thank you, Chairman. And I'm Tony from MTR. And nice to meet you all in this important event of ICE. I would like to use in a few minutes to share about the MTR climate change strategies. Okay. If you look at this photo, you realize, how this climate could affect the railway in terms of safety, flooding, and the derailment risk. And the key challenges to MTR, we are not alone. Everyone will have to face the extreme weather and the rain changing in the rainfall patterns, and also the ever rising sort of temperatures. And with all this extreme weather, we have to do all the planning well ahead. We adopt the life cycle cost approach to identify potential opportunity, and consistently we will update our design manual to cope with the latest, adverse weather changes. And we also carry out regularly the extreme weather and climate change impact studies to see how our infrastructures and our operational readiness has to be uplifted to face the challenges. And that all related to how we predict and prevent all these potential event attack to the railway operation safety. And on this climate change initiatives, I would like to partition into the 4 areas, including the climate adaptation and resilience and the green part. I think everyone will have a great interest about the flooding risk to the railway. And for us, we designed based on 1 in 2,000 years. And we have the station design always have a step of at least 450 mm. Everyone, when we go to the stations, you will see that. And in case we see a heavy rainfall and an early alarm of this coming heavy rainfall, we will erect the flood bots that if in case the water will get into the stations, and we will we provide the 1.2 meter, high level flood bots, and that could withstand even further sort of extreme weather attacks. And we also provide the floodgate in tunnel to block the water, in case it get into the tunnel or breakage of this tunnel wall leakage, etc. And all those slope maintenance as well, And for the emergency readiness, I think it is important that we have to take a proactive approach to look into how the rainfall actually developed and the area that actually attacked to the underground station, and then we will evacuate the station early enough before we have any potential fatal risk to the passengers. And on the precautionary measure, we apply a lot of technologies like the tree management technologies, seeing how the tree could fall or tilt under a big typhoon, and flooding monitoring system all along, and the drainage system inspections. And this is one of the examples that we adopt the technologies using the NIDA technologies and mount the equipment on the light rail vehicle so that the vehicle can survey the area all along and see how the trees branches actually develop, how the wind actually blow the tree branches, and eventually will cause a sort of a tree falling risk to the running railway. And for us on the green part, we commit a target to achieve carbon neutrality by 2050. Some of the actions, like we replace the treeless and almost finish this big project in 1 or 2 years' time, and we save 30% of the energy compared with the old technologies, and we use DVVF sort of technologies, and 20,000 tons of CO2 was actually reduced, and LED everywhere. Okay, and the Hinking station is one of the model stations that we apply a lot of green technology over there, and this is one of the stations that we win the BEAM certificate for that, which is the first in Asia. And for the light wheel vehicle, we also try on LED the solar panel on the roof. And for the bus, we also explore, instead of using diesel, we're exploring using a battery, or maybe in the future looking for hydrogen bus as well. And as I mentioned just now, the BEAM Green Building Certificate was actually, awarded to us, and that is the first in railway in Asia. And in future, how we are going to tackle to make our station greener. This is one of the examples that we will try to build a station that greener than before. And that's all I want to share, Chairman. Thank you.
Thank you, Tony. Now our last but not the least, our panelist, Mr. Samuel Kong. He is the Senior Sustainability Manager of the Hong Kong Jockey Club. Samuel has over 25 years of solid sustainability management experience, of which the majority is with multinational conglomerates covering a wide range of businesses, including beverages, aviation, catering, estate management, retail, shipping, and infrastructure projects. Samuel is currently the Vice Chairman of the South China Environmental and Safety Management Association and Director of the Hong Kong Institute of Qualified Environmental Professionals, past Chairman of CIWEL, former Director of the Hong Kong Business Council on Environment, and the Hong Kong Green Building Council. The floor is yours, Samuel.
Thank you very much, CM, and also thank you for Ed and KY and Joyce sharing. I'm Samuel Kong from the Jockey Club. Today I want to share with you what the club is doing on climate change. And before I get into that, I want to give you a little bit introduction, and in case you do not know, especially Ed. And the club is providing sport and entertainment service to Hong Kong. And I think you know best is that we provide the race event and also football wagering and Mark 6. And the race event is one of the attractions in Hong Kong. And in 2018, we have been selected by the TripAdvisor as the so one of the must-go event in Hong Kong. But after that, we have the COVID and the social distancing. We hope you can go back to Happy Wednesday soon and enjoy the event. And something you may not know that we are also doing is that we are providing a hospitality service, membership services. We have clubhouses, Happy Valley, Shatin, Base River, and Beijing. And we also operate, we design, build, and operate facility for the Hong Kong society as well, including Penfu Park, public riding schools, Khao Sai Chow Golf Course, and also Tycoon, and the Palace Museum is under construction. So this is the one I use to explain to my colleague what are the climate change impact to the club. So in 2018, during Typhoon Mangkhut, we had to cancel our race event because of the extreme weather condition. And when climate change comes, that will become more and more frequent. So not even typhoon, but also hot temperature and high humidity that will affect the horse performance as well. And upstream, that will affect our supply of horse feed and horse materials, and also the catering services. What we eat, that will be the food supply will also be affected. And that climate change will affect our water supply and also our transportation. So I look at that, I showed this to our colleagues, to you in the club, with 2 meters sea level rise, the Happy Valley Racecourse, Sha-Tin, and Base River, our main operation will be underwater. This is 2 meters only, not to take into account like the storm surge and also the extreme typhoon condition. And Joyce, because of DSD's help, Happy Valley, we have the underground stormwater storage tank, that the situation may be that better. That was an old photo we've taken with the flooding in the Happy Valley. So not just in Hong Kong, but taking a step back and we look at the whole Pearl River Delta, the Great Bay Area, and our operation in Chung Hua, and our supply chain will be affected, and our transportation to Chung Hua will be blocked as well. So these are the things that we may have to look at. And so that is not my own sort of like idea. This is the wording from our CEO, that climate change is an obligation, not a choice. So that's what we are doing on climate change. And I want to share with you, this is, I think that it's a concept everyone is using, but this is the way we are looking at it. So we have 5 areas to look at. So our own operation, how to reduce our scope 1 and scope 2, but we also have to look at our supply chain, our scope 3, our material used for projects and constructions. And another one is some of the speakers have touched on as well, is the adaptation and resilience. How can we protect our operation, our buildings, our facilities from flooding and adverse climate conditions. And the other thing is the offset. So even we do 1, 2, 4, I mean, we still have some carbon that we may not be able to offset, or we may not be able to reduce. Then we'll have to look at an offset strategy. But more important is the final one, is the change management. So if we are willing to change our behavior, some of the things we do not have to do. For example, if we are willing to turn up the temperature of our air conditioning by 2 degrees, then we don't have to do a lot of retrofittings and other things. And and also not the change in our behavior, but also a change in the governance. In order to achieve the climate change, we have to think about how we operate. And it is not just the responsibility of like FM or property or sustainability. It is everyone in the organization. So I'll go quick. This is what we are doing. We did our own solar last year. And then the management said, Sam, okay, do it 100 times. Do it all over in the club. So this is our strategy. And this is not the first one. We have done that in Khao Sai Chau. We have our solar ferry, solar golf cart, and we also collect the rainwater and for irrigation. In Khao Sai Chau, we have in Hong Kong the only desalination plant right now, and we are also applying that zero wastewater discharge and water harvesting concept in our race course in Chung Hua. So doing the things in our own operation is one thing. The club's purpose is also to act continuously for the betterment of the society. So we work with the NGOs to provide trainings and upgrade the NGOs facilities for like greening the buildings and etc. We are also training up young people on their concept on like climate change and collecting ideas for climate reductions. And we also sponsor the NGOs on installing solar panels and other things. So we have established the first in the world climate museum, and it is visited by over 1 million people so far. And it is it's still a very attractive location in the area in Hong Kong. So I'll stop in here, and then so maybe we can discuss, and if you have any questions, we can share and discuss.
Thank you, Samuel. Let's go into the discussion directly. The President in his speech brings out an important message: increasing productivity and efficiency as a tool to help combat climate change. He has quoted studies that over-specifications seem to be the norm. He mentioned that between 10 to 25% of the project costs were directly associated with avoidable errors. I wish to address my first question to the President. Can you give us some sort of examples on these errors and how can they be avoided systematically?
Yes, Patrick, yes, I could go on a long time about things that go wrong, and I'm sure practical engineers on the call will recognize a lot of the sort of things I'm going to say, but it happens everywhere in the process. I'll give you examples from different stages, but an example would be the client team fails to procure a relevant specialist to join the design team. Let's say, for example, they don't hire the fire expert on the building early enough. And so the design team proceed to design the building based on assumptions about the fire strategy, only to find when the fire expert is brought in that the building doesn't comply with the fire regulations or that there is a problem with the fire strategy and the design has to be done again. This sort of thing happens and it leads to delay in the program and wasted money on the design team. Here's a concrete example of a project I was involved in where a designer, major company, chartered engineer, used a Manning's coefficient to do their drainage modelling rather than a Colebrook-White friction coefficient. So not 1.5 millimetres, they used 0.015, designed an entire drainage system for a 100-hectare site, produced construction drawings for that whole 100-hectare site before anyone noticed that the pipes were completely the wrong size and later completely the wrong falls. So the entire design exercise had to be done again with a delay of 4 to 6 months, all of which involved cost and so on. Another real example where a procurement team decided to substitute the specification of the specification called for clay pipes. It was a design and build contract. The procurement person found that plastic pipes were cheaper than clay pipes and decided to change the order, so put in plastic pipes instead of clay pipes. They built it, they laid all the drains, and only late in the process, after it had been built, did someone realise that they'd made this specification substitution and hadn't checked with the engineer. As it turned out, there was hydrocarbons in the soil, which meant that the plastic was not safe and stable for the life of the project. They had to dig the entire drainage system up and replace it with clay. A construction project, sorry, I could go on, I'm going to give you one more and then I'll shut up. But another one is a major construction project, major, these are all sort of, £100 million plus construction projects, where there were 2 large pours going on. One was a structural pour for a major pile cap, massive pile cap, and the other pour was a major pour that was going on to build a haul road, about the same size. 2 different grades of concrete, structural concrete for the pile caps and raft, and non-structural lower grade C25 concrete for the roads. As it happened, there was a delay on the day of the supply from the company that was providing the structural concrete. The construction manager on the site didn't understand, didn't appreciate that they were different grades of concrete, and in order to defend the program, directed all of the road base or the road concrete wagons to the structural pour. They poured over 1,000 cubic meters of concrete and had to rip it all out. And so this sort of thing, when you aggregate it up, is where you get 10 to 25% of costs in construction being a result of avoidable error. And if we scrutinise our own organisations, our own practice, we look at insurance claims, you won't have to go very far to find these sorts of errors all over the place. Sorry, that's quite miserable, isn't it, Patrick? But there we are.
Let's have a little follow-up. When we talk about over specifications, very often,
Yes.
you know, the clients tend to be fail-proof. They are very conservative and they have the money. And as you have mentioned, designers, consultants, contractors, they are all benefited from the process. How do you think this kind of mindset be turned around?
Yeah, so just picking up, I'll come back to your key point, but just first of all, the first thing is that designers need to design for the code. You know, that's an absolute prerequisite. And if the code says that the factor of safety needs to be this, designers need to be aiming for that, with utilizations that correspond to the factors of safety. What we find over and over again, and frankly, the Cambridge research crew, the Bath research crew looking at this, found that designers are typically, they're not aiming for 100% utilization in compliance with code, they're aiming for 75 or 80%. They're building in global factors of safety for their own comfort, commercial comfort, and against future change and things going on, of 20 to 30%. And that's on the critical structural sections. The rest of them can be working at utilizations of 10 or 20 or so on percent. So there's it's not just clients being really restrictive and saying, sometimes that's right, yeah, sometimes clients do ask for a load of stuff, but the consultants will then specify more material because they want an extra factor of safety so they don't have any hassle further down the road. So returning to your challenge, which is how do we change all of this? Well, the first thing is people have to become aware that this is happening. So one of the things we're advocating is that designers should report on the utilization. They should be asked to say, how hard is the structure or how hard is the embankment working? How close are you to 100% utilized in the critical load cases and critical circumstances? Declare it, show me. And if I was a client, I would want to see lean design. I would want to see them doing that at a level of high levels of utilization. So I would say, first of all, the answer to your question is it's got to become visible. People need to know that this happened. And secondly, people need to start caring about it. And you've had a whole conference here talking about climate resilience and so on. People have to understand that if we're putting 20 or 30% more concrete into our structures, concrete constitutes 8% of global CO2 emissions. 20% of that is currently just because we are deciding to over-specify materials. And somebody has to turn around and say, that is not acceptable. We are going to stop doing it. But one of the big challenges we face, I'm not quite sure what the situation is in Hong Kong, but certainly in the UK, we have a challenge that the way that the supply chain is set up, it's really understandable that consultants will adopt very defensive design strategies because they're very worried that if there's something goes wrong down the line, we've got that high error prevalence, or if there's a late change, or if the contractor has a problem on site, that they will get dragged into sorting something out. And they haven't got the fee for it, and they haven't got the time for it, and so on. So it's not, you know, first let's surface the issue. Second, let's start to care about it, and then there's quite a lot of work to be done to unpack it and get it to work. What's encouraging is that, you know, the best designers, the best companies are perfectly capable of designing really lean, high functioning structures when they're in the right commercial environment. It's not essentially a technical challenge, it's essentially an attitudinal and commercial challenge.
So that's where we should have the right people for the right jobs.
and pay them properly and put them in the right risk situation, yeah.
So the next question is, I'm addressing to Joe, Tony, and Samuel. He says here, in general, there seems to be a subconscious tendency to report only the good news, but not the bad news. So hearing the presentations today, one possible take-home message may be things are under control, and the various infrastructure systems are fairly resilient and will, by and large, withstand the impact of climate change and extreme weather events. Is that really sufficient balanced message we want to give to the public as a profession? In terms of expectation management, can we be more honest about what might happen if we are struck by extreme weather events tomorrow? Who wants to take the challenge first?
Maybe I try out first, Chairman. I think it is important that we have to keep abreast of these climate changes and make resilient, because that in relate to the safety of the transport system, in carrying passengers. And with that, there must be some common protocol that we, like the Hong Kong Observatory or EMST or whatsoever government statutory body, that we set a standard in terms of the predictions of this potential risk to the society, and how the design and the construction, should take care of and predict the investment and upfront ahead, but not do more, not do less, in an optimum way. Well, risk is always is a crystal ball guess, but there are formulas and investment that there's a norm that people can adopt, and we must adopt a life cycle cost approach and benchmark with others how they actually dealt with when they actually encounter those extreme situations. I think that is an art, not a science. Over.
Joy and Samuel?
Let me do a little bit sharing about the expectation management to the public. Actually, we see there is opportunities about the risk of from the climate change that may help us to promote our what we are now trying to introduce is the resilience measures to the public. We have to do more educations or promotions to let the public know, have the awareness about the risk due to the climate change and the need for our infrastructures to strike a balance between the grey infrastructures, the structural measures, and also the needs of the resilience measures which help to improve the resilience of our cities, at the same time to strike a balance for the on the cost benefit on the cost effectiveness. We need to take these opportunities to let them know there's not only structural measures, those resilience measures, such as the use of demountable flood barriers, is actually very helpful to help the residents or the shops to protect their self and properties. Actually, we are trying to set some examples in, in Tai O. We have an early alert system when the Hong Kong Observatory sent us the early alert to predict that the sea level has arrived as a certain level, exceed the certain threshold. Then we will have our emergency team to set up the resilience measures and a demountable flood barrier there. And this is quite successful to protect the publics there. Yeah. I think this is the way forward of how we adjust the public expectation and try to promoting the resilience of our city. Yeah.
Samuel?
Yep. Thank you. So I'm not trying to be sub-optimistic. That's why I show you the flooding risk map that I used to share with my colleague. Flooding in Hong Kong, I think DSC and the government, they are looking at it, but as an organization, we also have the responsibility to look after our own operation. And when I take a step back and look at the regional issue, and we have the cross-border transportation from Chonghua to Sha Tin and Happy Valley every week. So that one, if we have the climate change affecting the transportation, that will affect our own operation as well. And also for building energy efficiency, the current technology can only provide like 60% of the solution. Some of them we still don't know. So we still have to find a way to tackle our problem. And at the end of the day, we are looking, we may also have to look at offset. But I do not want to be all the way pessimistic. I also want to highlight to everyone that there are challenges, but there are opportunity as well. Like for the renewable energy, the solar that we are doing, it has a very good payback, and it will reduce our bottom line that we will be operating more efficiently and at lower cost in the future.
Thank you. When we talk about building resilient structures, people have in mind always think that we are building something more robust. But this also means that in that case, we have more embodied carbon in the structures. This is like a vicious circle. Is it some kind of conflicting against the kind of our goals of reducing carbon? So when we are trying to combat climate change, to actually introduce, use more carbon. Anyone has any ideas on this? Ed?
Yeah, so, well, look, you've got different strategies for dealing with this sort of thing. You can adopt a defensive strategy of building higher, stronger walls, of putting more thermal controls and all the rest of it, or you can adopt adaptive strategies where you react to the events. And I think Joy is absolutely right in saying that you've got to work with communities to redesign the way of living so that they can adapt to events. And it's interesting, I've done projects in Cuba and on the Bengal coast where their approach to rainfall events is go inshore. Hurricanes and surges, they move, people move. They accept certain levels of property damage as part of the solution. And so I think those sorts of things are really important. I think we underuse natural-based solutions. At the moment, we rely on very heavy, high carbon technologies around concrete and steel. And there's a lot of work to be done that we can do in mitigating the effects of climate change using nature-based solutions. And I really think as an engineering profession, we've got to really accelerate our work in nature-based solutions over the next 5 and 10 years so that we can start using this stuff in anger. So I think I would say there are sort of a couple of dimensions to this which end up in an answer that says it's not necessarily the case that adapting to climate change and providing more resilience increases the carbon associated with our infrastructure. We can come up with strategies that both reduce the carbon we embed in our infrastructure and adapt to the changing climate.
Yeah.
Will that be an
Thank you, Ed. I want to add to, I think we also have to look at the life cycle, sort of like the carbon footprint of the project. So there are methods that we can use to reduce the embodied carbon footprint in the material we use and in the construction process. And also one important thing is we design and operate the thing for a long time. So we do not sort of demolish it and then rebuild a new one in short time. So as in the club, we hold on our facility for 150 years and we're still using it. So these are if you design it and for like long-term use, then you put in the factor of the operation efficiency and use into consideration. and then the life cycle will give you a balanced solution at the end.
Would there be a new ICE initiative?
Yes, I would like to echo here to add that about what he say is the nature-based solutions. Actually, our department, DSD, is also promoting what we call blue-green drainage infrastructures, that we are trying to using some like green roof, rain garden, some green measures that it's to help to reduce the need of the great infrastructures, and at the same time help to promote or reduce carbon emissions. And at the same time, I think we can make use of some new technologies that help us to optimize the design so that the needs or let's say the size of the water tank, which requires the many cement, can be reduced so that it can also help to strike a balance between the blue-green and grey infrastructures, and also help to promote the carbon zero.
May I chip in here? I think it is important that, as what just mentioned, by Sammy, that the life cycle assessment is essential. I think it is important that we have to adjust the embodied carbon and reduce it, and we also have to look into the operational carbon and how that material actually carry what sort of footprint in operating it. And that is a whole life cycle consideration that has to be taken into account. Over.
So I have the last question is for Tony. It's about we were all concerned like Chengdu incident last year where we have all the flooding of the subway. Can we have your assurance that this is not going to happen in Hong Kong?
I can assure all members here, we have a very good, Hong Kong observatory, and also all the stakeholders that work with the government, the drainage department, and all this. They always will give us early alerts, about the potential flooding, and all this barrier and this floodgate, are built strong enough to withstand the level of the floodings. And when we detect by all IoT around the rainfall, etc., we will escalate the level from the amber, red, and black, including our own internal level of attentions. Therefore, we will have taken a timely actions to stop train from surface, to stop train from going into a tunnel that could be having a flooding risk early enough. I think that alert system escalations is important. We cannot stop the sky from heavy and cat storm rains, but we can predict and take action timely, and so as to not let any passengers that can lock in the trains, lock in the station, that they kill their life. And equally, as I just mentioned, for every station, we have this 450 mm level that can withstand 1 in 200 years of flooding. And actually, the whole Hong Kong drainage system is designed as per the 1 in 200. And when I erect the floodboard for 1.2 meters, or for that sort of level, and actually for that height, the level of the sea level and etc. can actually withstand 1 in 1,000.
Oh, that's good news.
Therefore, I can do that for that. Thank you.
So our time is up. So thank you for Ed, Joy, Tony, and Samuel for a very interesting discussion. So see you sometime. Thank you. Bye-bye.
Bye-bye. Bye-bye.
Bye-bye.
Bye-bye.
Thank you, everyone. May I invite all of you to stay online and then take a photo together. Tony's still here. Okay, maybe we will still go on with the group photo taking. 3, 2, 1, cheers.
Cheers.
Thank you very much.